Hello viewers, in this lesson we are going to learn on how to determine the turning points of a curve. And before we start our lesson, if it is your first time to get into my channel, kindly click on the subscribe button, turn on the notification bell so that you'll be updated with more of this. Then we can determine the turning points of a curve. So how do we determine the turning points of a curve? We have a question here. The equation of a curve is y is equal to x cubic plus x squared minus x minus 1, and we are supposed to determine the turning points of a curve. We also call the turning points stationary points. And how do we determine them? So we will take our equation y is equal to x cubic plus x squared minus x minus 1. We are first going to find the gradient function of our function, or what we call the dy over dx. And dy over dx, we are going to differentiate the function of y with respect to x, and we will have 3x squared plus this one, we take it here, it becomes 2x. Then when we differentiate x, it will give us a 1. Then for us to determine the turning point of a curve, what we need to understand is that the change in y over the change in x at turning point is equal to 0. That is at turning point. The change in y over the change in x is equivalent to 0. So we are going to equate our dy over dx with 0 so that we can determine the values of x, and we have 3x squared plus 2x minus 1 is equal to 0. So this one is a quadratic equation, so we can solve it using factorization. We can first find the product, and the product is equal to negative 3, that is a times c. Then we can find the sum is 2. Then we can find the factors, which are the two factors, or the two factors that are going to give us a product of negative 3 and a sum of 2 are negative, they are the product of negative 3 and the sum of 2. The two factors are going to be negative 3, negative 1 and 3, negative 1 and 3. Then we can continue to factorize. So it's going to be 3x squared plus 3x minus x minus 1 is equal to 0. So we can proceed to factorize each, and we are going to get 3x into bracket x plus 1. Then the other one will be minus 1. X plus 1 is equal to 0. Having that, we can conclude that 3x minus 1, x plus 1 is equal to 0. And having those two, this means either this one or this one is equal to 0. So we are going to have 3x minus 1 is equal to 0, or x plus 1 is equal to 0. So when we determine x here, we are going to get our x is equal to 1 over 3, or a third, or our x here will be equal to negative 1. So after solving the quadratic equation, we have been able to observe that it has given us two possible values of x. Now we need to determine the value of y, simply because we have two values of x. So if we have two values of x, definitely we must have two values of y. So we can rub or erase this part and utilize what we have in our new chapter. So having x as a rad, we can be able to determine what y is. So if we say x is a rad, our y is going to be a rad to power 3 is equal to 1 over 27 plus a rad to power 2 is equal to 1 over 9 minus x is a rad minus 1. So we can use an electronic calculator to determine that 1 over 27 plus 1 over 9 minus a rad minus 1, that will definitely give us y is equal to negative 1, 5 over 27. So our first turning point is going to be a coordinate in form of x, y, and it will be a third, comma, -1, 5 over 27. That is our first one. Or there are two possible turning points. We are now going to find the value of y when x is -1, and we can lab here and utilize this area. And we are going to, our equation is y is equal to x cubic plus x squared minus x minus 1 when our x is -1. When our x is -1, we are going to have y equals to -1 cubic is -1, because an odd number or a negative number raised to an odd power is equivalent to a negative number. So it's -1. Then -1 squared is 1. So it will be +1. Then minus 1, it will be +1. Then -1. And we are going to have our y as -1 plus 1 is 0. 0 plus 1 is 1. 1 minus 1 is 0. So we are going to have our y as 0. And our second turning point is going to be -1, 0. So that is our second turning point. And this one was our first turning point. So we can therefore conclude that the turning points are a third, -1, 5 over 27, and or -1, 0, and -1, 0. By doing that, you have already been able to determine the turning points of the curve. So that is how we approach questions on determining the turning points of a curve, and I believe that you have understood. So I remind you again, my name is Teacher Asaf or Teacher Karaoke. You can click on the subscribe button, turn on the notification bell so that each and every time I upload a new video, you will be updated. Thank you so much. Let's meet in our next lesson. Thank you.